already seen a couple of things where we've noticed there's different types of data. We've got integers and we've got float numbers, but I want to talk a little more about what those look like then to us as we go through there. So we also may call it a literal, and that's the same idea as a character string. So if you see this term literal, that's what it means. So make sure you've read through in the book about some of these ideas of what we can do with strings. We're gonna start working with a lot of them. These escape sequences. So the key above the enter key, because I tend to, for whatever reason, my brain can't make sense of backspace / or backslash and a /. So I always just remember above the enter key. The most important ones we use a lot are the new line and the horizontal tabs we use a lot. But if we need to put in elements that are also part of an escape sequence or a control key or something, we can actually do that also. So we'll use those as we go through over and over again. All right. We talked a little bit about variables and about how we can do them. So this, for example, is that idea of using an underscore. That's one model. I personally like that, what we call the camel casing. As long as you're consistent, it doesn't really matter. But we need to make sure that you're consistent, that you use things that are self-documenting. Use these comment tags. I use those all the time. And you can actually put them at the end of any kind of content. So, the book talks a lot about numbers. And the reality, underneath everything else this computer does, it really works with zeros and ones. It's only numbers we're working with. And so we still use them in all kinds of other applications, but the very basis of what we're doing is based on numbers. So, a couple of limitations of Python. So, Python has some limitations. The integers, so if we were writing integers, we could go on forever. An integer literally has no range from bottom to top. However, for us, in Python, we do have some limits. And so it's got a limit negative and a limit positive. And there's an error right there in this slide. So it's not 21 to the 31st, it's actually just 2. So in other words, we go down essentially to 2 to the 31st power, and we go up to 2 to the 31st power. And because we have to include 0 in there and a couple of other little weird quirks, we use up 64 bytes to get that. So that's where that number kind of comes from. So 2 to the 32nd negative, 2 to the 31st positive, minus 1. And that's because our computer also counts 0 in there. So they're a huge, huge number, but they do have some limits. And we can run into, depending on what you're doing, a problem with them being not big enough. So if we look at a real number, so in other words, those numbers that have a decimal in them, or that there's a fractional piece, or again, they can go on forever. But we have limits in Python because we have to store that value. So ignore this piece here because that shows a huge number of decimals. So we can go to 10 to the 308th power. Well, that's a huge size. But what we really run into more is a limit of how many digits, including after the period, we can go. So we have some limits on that fractional side. And so typically we'll say about 16 digits long. So that's about our range. Now, there's some ways we can extend that and ways we can cheat a little bit, but that is typically the limits of our data size in there for numbers. Python will also let you express them as scientific notation. You know, that's where you take a small number like 3.78, and it's 3.78 times 10 to whatever power. So you can write very large numbers in kind of a shorthand. We can use that. I don't think anything we do here we will require you to use scientific notation. But just remember that you can do that. The next thing we got to look at is how do we convert things into these characters that we're going to use. So we know it's all numbers, and we know it's all based on zeros and ones. So if I grab the right one, and it must be this one. Well, I'll just open up another one. So the way it converts, I don't know where I threw it. Somewhere in there I had a chart, and I managed to throw it somewhere weird. So it takes essentially the very first part, so 0 through all the way through 256, and there's a lot of extra characters in here. Most of the ASCII charts only show you to 127, but that's enough to show us what all the capitals are, what all the lowercase numbers are, all these symbols, and then we have some other ones that you probably haven't seen, like a horizontal tab, line feed, all these different things. Those are all actually part of what we call that ASCII table, ASCII. So this 0, that represents a 0 in binary, and then all the way down at 256, or 255 actually, because we start with 0, is the last character in there. So we use 1 byte, B-Y-T-E, to represent what these are. So if I write a note and I want to start it with a B, then I know it's decimal 66. Well, that's how we store letters inside of almost every computer. We use ASCII. Now, the one problem we have is, or one of the problems we have is, there's a lot of languages that the character set doesn't fit in 256 spaces, in which case we can also use something called Unicode. Unicode allows us to have 35,000 different characters, but when we want to simplify it, this ASCII works pretty well for most of what we're going to do. So you can find all different kinds of ASCII charts. They all really say the same thing, because that's a defined standard of what we're going to look at. So if you're ever looking at it and you go, man, I don't remember what this ASCII code thing is that my instructor was babbling on about, you can grab them about anywhere. And we actually have a couple of functions to help us out converting back and forth. So if I type in a ORD and I put in a value inside a single quote, it'll tell me what number it is on that chart. So ORD of lowercase a, ORD of uppercase a. Well, I can also go backwards. So I can also say then character string 65 is an A, and we can look at that, and you can try that if you are looking at that. One of the things we did the other day, for those of you that are also in security, cybersecurity, is we used these very same commands to be able to do something called an XOR. You don't need to know that right now, but so if I did, and I put in with a single quote, and I put in the letter Z, it's going to tell me, hey, that's 90. But what's interesting is if I do a lowercase z, I get 122. Well, why this becomes important, when you want to use these characters to sort, or you want to put things in alphabetical order, there's a very clear difference between a capital letter and a lowercase letter. And depending on your application, you may need to flatten those out. In other words, convert them all to lowercase to sort those, because a capital Z would come before a lowercase z, and that may not be what your intention is. So those two commands are kind of interesting. And again, like I said, we use them when we do a lot of cryptography or something like that. We can pull in this ASCII character set and pull in some information. So let's look at a couple of different operators. Most of us have figured out all of these, except there's a couple we haven't talked about yet. So, negative or negation. All right, that's just a negative symbol. Makes sense. Exponents are just 2 asterisks instead of 1 for a multiplication. Well, all right, that kind of makes sense. And if you're ever curious, you can always put something in here. So you could say 2, and say we wanted to go to that 31st power, so we could see how big a number it is. So 2 billion, if I remember correctly, if I have the places right. Yeah, so 2 billion different possibilities up there. All right, well that makes sense, and I can do a negative. And so it's even sometimes if you don't have a calculator, hey, you can just pop things in here and say, I need, 437, whatever number I just randomly typed, and I can get an answer. So it'll give me some of those things also. A division, well, we've seen the division before, but we have a couple of others. So addition and subtraction, those make sense. But then you see these ones here, and it's a double divisor or the percent sign. Yeah. So maybe we need to think about what these are going to do first. So if I divide 10 divided by 3, I get a repeating decimal. That makes sense, right? We've all done that. And notice where it stops, it just does something here, it just chops it off. Alright, and it says, alright, 335. It magically rounded up somehow to 5. Not really sure how, but it's one of the issues with math we have to deal with is, what does it do on these repeating numbers, and how does it figure that out? But if I do the same thing with a double divide, whoa, it just chops off the left-hand side of that at the decimal line. So it just shows me that. Huh. Well, that's kind of weird. Maybe it's useful. Maybe there are times when I need to do something else with that end piece or the fractional piece, but I just want the whole number of it. Well, I can use that in doing that. But now what happens if I do this? So 10, and then the modulus operator. Oh, how does it do that? So we need to work a little bit and think about this just a little bit. So the modulus is kind of different. Oops. So it's giving us, so when we look at it, it says the remainder or the modulus. So when I look at that, oops, where did I lose it? Come back. Got too many things open. There we go. All right. So it gives us a remainder. So 10 divided by 3. I do get a remainder, and that remainder is 1. Here, if I put in as a float, I still get that 1. So in some cases, I may want to find out what that remainder is. So that is a quick way that I can do that. All right. Pull this out of the way. So, for the most part, the other rule we have to have, and if you've been on Facebook and TikTok and everywhere, they have these short little math problems, and everybody argues about what the right answer is, because apparently how to do things in an order of operations is no longer taught in schools. So, we have to look at how does Python evaluate these expressions. So, in Python, the highest order of operation is the exponents. Well, that's familiar. The next piece, and this one seems a little weird, that's really just that negative sign. So if you're converting something from a 2 to a negative 2, we call that unary negation, and that comes next. Then multiplication, division, and that modulus are all evaluated before we do plus and minuses. Plus and minuses are evaluated before the equals. And the equals is not a math operation, it's that assignment operator. So everything gets done on a math operation before it gets shoved into the left. And I'll show you how we can do that. So, so if we have a long expression, and so I'm going to say value equals, and that's where that's that assignment operator. It's not really an equals. So if I said 1, 2, 3 plus 45 times 2 to the 5th power, something like that. So it doesn't start here and add this to 45 before it multiplies it. Which operation is going to go first? So look at our order of operations. So we're always going to do the exponents first. So it's going to do 2 to the 5th power first before it does anything else in here. Then it's going to evaluate, all right, I need to do the next step because multiplication is more important than addition or subtraction. So it's going to say, all right, 45 times 2 to the 5th power. And then it's going to add that value to 123. And last, it's going to shove that all into the value here, our variable called value. So if I hit enter, all right, $1,563. All right, I can buy that. That seems appropriate. Well, let's change this a little bit. And what I could do is I could change the order of this by using parentheses. So 1, 2, 3 plus 45 times 2. So it looks very similar. Put my assignment operator in there. Value equals. So now let's see what happens when I run that. And notice I get a different number because now we added those together before we multiplied. So if you ever see one of those puzzles on Facebook and you're trying to figure it out and everybody's arguing whether it's 9 or 1 or 6 or 12, pop it into Python because Python follows those standard rules for the most part. There's a couple of things like this equals being on the last thing we do because we have to shove it over. So everything else is what we call left associative. So it works from the left to the right. This equal sign works from the right to the left because it's got to take things in the right and shove it over there to the left. So when you're working with math, make sure that you see those differences. All right. Couple of other weird quirks. Because we don't have to define at one step and say our variable is a float or it is a integer. Sometimes we have to be a little careful because we can get a number that we don't want. So here we could say 3 divided by 4 and it's going to go, oh, it's 0. Oh, wait, well, hold on. Why is it 0? Whereas we know if it's 3 divided by 4 in our brain, that it should be 0.34. But if we have all of those set as integers, the closest integer it's going to truncate to is 0. Because when you convert into an integer, it doesn't round off like you do in your brain. It just cuts it off or truncates it. So we can look at those and you can see the same thing if you experiment with your idle shell. So if I did 6 divided by 9, I get a decimal number in there. But only because for whatever reason it's considering that already a float. So in some cases, if it says that those are still integers, you're going to get that truncated off. And so in both cases, what it does is it starts at the 0 and just chops that off. So let me go back up here and I'll call it value equals 3 divided by 4. All right. And now if I print value, it's going to say 0.75. But if I take value and I say I want to convert it to an integer, it should chop it to 0 there. And so here we actually did that. So it said, hey, it's 0. Now internally, it's still showing it here. But when we did the integer function on that value, so what I would have had to do is actually say value, to convert it permanently, I would have had to say value equals value, or the int of value, and then it would be permanently assigned to that. So value, print, value. So you have to be careful. It chops it off. And so if you're counting on it rounding up or down to a level, it's not going to do that for you, because it just chops it off right at that decimal point. So anytime we do what we call mixed, where we have a float times an integer, it automatically converts it to a float. So it does that for us really nicely. But if we're doing an input, it's always going to be a string. So a couple of things that we can do. There's some mathematical tricks we can use to make it come out correct. So here you can see the difference between a float and an integer. And so if we say it's an integer, it drops it off to 3. If we have an integer of 33, well, that looks perfect. But there's some mathematical tricks that we're going to work on. So here, for example, 6.75 you would think would be 7 if it rounded it. So we need to do a round first, and so you can round your integer. So round 6.75 takes it up. There's some other ways you can do it. The easiest way, and the way we used to do all the time, was whatever precision you wanted. So if I wanted it to a decimal point of 1 here, I would add half of that value, and that would automatically bring it over the limit when it would truncate. But now we've made it kind of easy. We've got all kinds of different pieces. So one thing we have to be aware of is if I have profit, so in this case they say profit equals a float, and they wanted to print $string plus profit. Well, that's going to error out because you're trying to add or concatenate two things together that are different variable types. So what you can do is then convert your profit to a string and make it look really nice and pretty and say, oh yeah, it's $1,055. But you have to remember where you're displaying it is actually as a string. All right. Couple of other items really quickly, because we're going to get into some of these, is we can bring in other modules or other pieces of code. And some of those are pretty interesting. So there are some built-in help features. So if I said help print or help round or help int, it's going to give you a little bit of detail about it. It's not always as useful as you would like, but sometimes it's kind of handy to know if you don't have any other ways on. So a lot of stuff we load up automatically. So we load up round, and we load up all different kinds of other things, but we don't know exactly all the functions that you're going to need. So one of them that we load a lot is the math module. The math module has all different kinds of math functions that's already built into it, and we can use that then with the dot notation. So math.pi, math.square root, all of those kinds of functions are built in. We need to load that module, and you can import a couple of different ways. So you can import just a couple of the items, and when memory was really small and we had to be very, very careful about how many things we loaded, this was a consideration. Today, none of these computers in here are incapable of loading the entire math library. So we don't have to, here we said from math import, and you were just importing these couple of items. honestly, what I do at the beginning of my programs now is I just say import math, or import random, or import whatever library it is I want to work with. And so here they've just showed what those are. So here's pi and the square root of 2. And again, you'll look that they're probably about 16 digits long. This is an old school way of doing it. And honestly, so our book shows you this from math import all. So this asterisk is a wildcard character. If you just simply use import math, it will actually do all that. So there's an easier way to do those at this point. So the documentation here. So sometimes we want to create what we call our main program. So all of the things like our variables, our ancillary pieces, we load in another section, and then we're going to create what we're going to call our main program. And so we're just kind of setting you up for how we're going to figure out some of these other things. So what are we going to do at the very beginning of our program? We're going to import modules. We're going to try to figure out what variables we need. If we need any user data, we're going to put it into variables. And then we're going to process and display. So we take data in, we modify it, and we print data out. So this is a pretty horrible way to do it, by running everything inside of the command line. I like to show how we can do this by running that script file. Now, they're showing a slightly different way, and I prefer just to click and use the run. So the other way you can run them is by hitting that PI file, and I showed you that and what happens. So in Windows, this is a problem. Mac actually leaves it open for you, which is kind of nice. And the Linux version actually does too. So this is really only if I'm natively doing it in Windows. You need to put in like a blank input statement at the end to hold it open, and we showed you that. So we've kind of went through a lot of content. Your brains are probably exploding a little bit here. Close the ASCII now. So what I want to look at is some of the content for this particular chapter. So we have covered a lot of these assignments already. We only have a couple left to do, to kind of look at. Now, I will say as we get further and further in here, I'm going to take away a little hand holding as we go. So you've noticed I've already started to peel out a couple of assignment pieces you need to do and such. So I want everybody to do it, but you have to be willing to try and experiment to also get there. So if I remember correctly on my scribbly note, go Cengage, is we had looked at 2.5, but we had not completed it. Is that correct? Did we do? Let me open it up and make sure. I have that we started on a note, but I'm not sure that we finished it. So did we finish this one? We did? Okay, perfect. Thanks, guys. All right. So let me jump to 2.6. Some point it'll load. I will say, if it seemed to be last night, Blackboard was back to being fairly quick, but the other night it was pretty horrible. So I'm going to take some of this out really quickly because obviously I've already worked on it here. So this one gives us a formula and says kinetic energy equals 1/2 mass times velocity squared, where m is the mass and v is the velocity. Okay. So it really said modify, but I think we should probably start over a little bit and look at what we need to do. Obviously, I'm going to keep this piece because that's the same. I don't need to reinvent the wheel. I already have input statements that say request the input. And down here, I kept the object's momentum is, and then we could say the object's kinetic energy is now. So what we need to do then is figure out how do we get to KE. So KE, or kinetic energy, now, because we use uppercase as kind of a constant, I'm going to do it as lowercase just so it doesn't drive me crazy. And I know I'm going to assign some value to it. And I have an entire list of operations here. So 1/2 times m times v squared. So what has to occur first? Which operation in here do you think has to occur first? So from our order of operations, we don't have any plus or minuses, right? So we know that those are out of the equation. But let's take a look at a set of values we've got. So I'm just going to do some free typing here. So 0.5 is the same as 1/2, right? 0.5 times mass, and I'm just going to put in the number down there, 5 times 2.5, and then if I'm looking at this formula, then I'm going to take the whole thing and I'm going to square it, right? Is that going to give me the same answer? So that's what I have written here, 1/2 m times v squared. So is that going to give me the correct answer? Or is that following our order of operations if I force it to do that way? Well, let's see. You can always run this, and then, so what I'm just going to do is rem out these, or remark these out. So it won't get that data. It's just going to take this hard numbers, and I'm going to run it. And, oh, it doesn't have that one for, hang on, I've got to rem this one out also. Alright, so I'm going to run it, and it's going to say 39.0625. Wait a minute, I have a test value here that says it should be 15.625. Well, maybe this order of operations has something, there's something to it. So what if I did this? I'm going to take out my parentheses. So I'm going to leave it like, so 1/2 m times v squared. So let me rewrite that a little bit. So I'm going to have 0.5 times mass, which is 5, times 2.5 is the velocity, right? And I know that this piece we have to square. And I would think, based on our order of operations, that I need to square that first before I multiply. So now if I run that, I get 15.625. Oh, that number's correct. Well, let's see if Python is as smart as we think it is. Is that what it's going to give me? It is. So it can interpret that better than we can on the Facebook puzzles. So I'm going to delete that now. And I'm going to say then, all right, so kinetic energy is going to equal then 0.5 times mass times velocity Alright, does that sound right? And I need to make sure we let mass and velocity get back in here. Alright, so now if I run that, and I put in my test values, I get a value that looks really, really close. So this one actually isn't that hard. Now, you do have to keep your momentum calculation, because if I try this right now, and I say run checks, I'm going to get, oh look, I got a 50%. Well, the reason that happens, test for mass and then I put in a test case. And if you actually open those up, you'll see that it says down here on these results, I didn't get the momentum at all because, well, I don't have it anymore. I've just kind of taken it out. So you'll have to make sure you have both the kinetic energy formula and the momentum formula from the previous assignment in there. So in this case, I'd get a 50% because I don't have all of my pieces there. But the hard part in this one is making sure that that order of operations is working like we think it is. And in this case, Python's pretty smart. It goes through and it says, all right, there we go. So sometimes we overthink these a little bit, I suspect. Make sure that it prints out. One thing I have noticed weirdly is it very much looks for these key phrases in the way that the parsing works. So sometimes over here, I will just copy and highlight this so that I have exactly the same phrasing here. So the object's momentum is, and when I paste that in, I just do a paste, and so I have exactly the right wording. So that's my tip of the day on that particular problem. All right, close that. And again, these are recorded, so you can look at them. Let's take a quick peek at 2.8. Yeah. So we have a little more convoluted program or problem here. So light travels at 3 times 10 to the 8 meters per second. A light year is the distance a light beam travels in 1 year. Write a program that calculates and displays the value of a light year. Okay. So seconds in a year, we can calculate that, and the rate, and then we know what it's supposed to come out as. And it doesn't actually ask for any input, but it's going to have a print statement down here. So I'm going to say, I'm going to do this. Before I get too far involved, I'm going to put in my print statement. Print, and I'm going to copy this. Now, I know that I need a quote mark here, and a quote mark here, and then a quote mark and a quote mark at the end. And I'm going to have to put some kind of variable in here. So what might be a variable name we could use for how many miles in a year? Or how many meters in a year? So I might call it yearly or year distance. You can make whatever, and I'm going to set it equal to 0. And so now I know that that's the variable I'm going to put in there. So then I could put in year distance. Alright, so if I run it right now, invalid syntax, done something weird. And it's probably in this last one here where it says file 9. Print, light travels blank, comma, year distance, L. Like that. Alright. And so right now it's going to say light travels 0 meters in a year. Well, we know that's not right. So we may need a couple of other variables. So seconds in a year, maybe we could figure that one out. So maybe even say year seconds. Again, whatever you want to call it, it doesn't matter. And we know that then that's going to be this 365 times 24 hours in a day times, now, here you have a choice. You could just do 60 times 60, right? But it's marginally one keystroke less to say 60 squared of 2. Okay. And I may want to just print that out then, so I can see if that number sounds correct. And now I'm going to run this real quick. 300 and, okay, does that sound right for the number of seconds in a year? You could always do it on another calculator and check it. Or you could go, I don't trust this, that it did that in the right order, so I could say 60 times 60, run it again. Oh, look, it's the same answer. So I'm just going to leave it that way with the 60 squared, because it does actually save us a little bit. And then, so I'm probably going to take this one out for now. So now it doesn't, you don't see it anymore. And then it says the rate is 3 times 10 to the 8th meters per second. Yeah. How do we get that to calculate? Well, so our rate is equal to 3 times 10 to the 8th. All right, and then I'm going to print rate just to see what it looks like. So, all right, that looks kind of like a number I've seen before. Well, now if I have a rate and the year of seconds, then I can probably come up with this year distance. So I could say year distance is equal to then rate times, what do they call it, year seconds? Alright, so now let me get this other extra print out of the way. There we go. Alright. So now we'll check it out, see if that looks. Light travels, holy cow, a lot of meters in a year. Okay, so it might be right. So let's go in and we'll take a look and see what it does when we run our checks on it. As it checks very, very slowly. Oh, look at that. Now, I will say that I've noticed this as kind of a quirk. It sets at 0% for a little bit, even though it sometimes has the check marks here. If you wait, and sometimes it'll take 30 seconds, it'll pop to the 100%. And that seems to be a Cengage quirk in there. So, we got the right solution. We didn't hard code the number of meters traveled. And we got the right answer. So that one shouldn't be that horrible to complete. What they're looking for is the correct solution, and then that. So if we wanted to convert that to kilometers, we could certainly do that too. We could change kilometers to meters. We could actually do a conversion to miles if you wanted to do that. So hopefully that's not going to be the most challenging one. And so let's take a peek really quickly at number 10. Come on. Alright, so now we've got one that's going to be a little more challenging. So, an employee's total weekly pay equals the hourly wage multiplied by the total number of regular hours plus any overtime pay. Overtime pay equals the total overtime hours multiplied by 1.5 times the hourly wage. Alright, write a program that takes as inputs the hourly wage, total regular hours, and total overtime hours, and displays an employee's total weekly pay. So what we're going to put in is the wage, the regular hours, and the overtime hours, and come up with a pay scale. Now, later on, we're going to take this similar thing, and we're going to just put in the hours and calculate that out directly, but I think this one might behoove us to get a notepad out or something to write on and kind of think about what we're doing. So we know that we're going to take in number of regular hours. We know that we're going to take in number of overtime hours. And we're going to take in a pay rate. So as I look at this, the first thing I'm going to probably do is I'm going to go ahead and create another variable up here, and I'm going to call that overtime pay rate. And I know that that's going to be pay rate times 1.5, right? So when we get overtime, you get what they call time and a half. Now, there are other organizations. So I have a friend of mine who works in a union shop where their overtime pay is based on daily hours. And depending on where they land over so many hours, they get 2.5 times their regular wage every day. But that doesn't always happen, so sometimes it's not a great thing. But, all right. So then we've got to calculate regular pay, or regular time pay, whatever you want to call it. Regular time pay. And I think that's going to be then that regular hours times pay rate, right? I know I'm going to have overtime pay, and that's going to equal overtime hours times overtime pay rate. And then to get the final result, then I need to add those together. So I have total pay is going to be regular plus overtime. Does that make sense? So I look at what it's asking for, and it says enter the wage, enter that, and then it doesn't ask me to break them down in any other way. So I only need to put in that outside one. So I'm going to first put my variables down here. And so I know that I'm going to enter a wage, so I'm going to say wage equals 0, so I have that one in there. I know I'm going to have regular hours, so reg hours. And I'm going to set that equal to 0, just so, again, I'm cleaning house on those. And I'm going to have overtime hours. And I'm going to set those equal to 0. And I'm just going to list all the variables I think that I need in here, and that's why I worked it out on a sheet of paper. So I'm going to have, so I've got my wage, I've got regular hours, overtime hours. So now I'm going to have to calculate then overtime rate. Now, here's something important. I'm putting that at 0 right now, and we know that that's not what it's going to be. I don't have yet, as this program works its way through, I don't have an input of what those wages are yet. So I'm going to have to calculate that later on. So then I'm going to have a sub total, or wait, let me do it this way. Let me do, what did I call it? Regular time pay. We'll set that equal to 0. Overtime pay. We'll set that equal to 0. And total pay. And we'll set that equal to 0. So I have all these variables in here. So I think that's all of them that I will need. Now, if you had other features like, hey, what's your name, and print that out, those kinds of things, we would add those. But for now, this is what it sounds like they're requiring. So now I'm going to put main code. So I know that that's my variables up there, and I'm going to separate a little bit. And so I'm going to have to do a couple of input statements. So wage equals input. And again, I'm just going to steal these so I have exactly the same thing. This makes life a little easier sometimes. Enter the wage. And then I'm going to say regular hours equals input. Then I'm going to put in here that one. And then I know I need to ask for overtime hours. So overtime hours equals input. And again, I'm going to just grab this real quick. Enter the overtime hours. So now that I know those things, now I can calculate what overtime rate is. So overtime rate equals wage times 1.5, right? Because now we know what it is. And then we can calculate a few other things. So I can calculate my regular time pay. And that's going to be my regular hours times regular rate, or I think we actually call that wage, don't we? So wage. All right. And then we got to figure out what that overtime pay is. So overtime pay is equal then to overtime hours times overtime rate. Perfect. All right. So now we've calculated all those, and we need one more. So we have that total pay, and that's just the sum of, so it's going to equal regular time pay plus overtime pay. Okay, and so then we have to output this in some kind of a statement. So print. Here I'm going to grab this again just so it says the same thing. The weekly pay is blank. All right. Now, here's where it gets a little tricky. So I want it to look, and I need it to look exactly like this, where it said I need $899. So back in the spreadsheet, you have found there is a model in here where we put numbers together. So if you need to put that together, you can actually find how to do that in here. So these slideshows actually have some information. So to do this correctly and get points, you're going to have to do that. So right now, if I hit submit, it's going to give me a pretty poor score. And in fact, if I try to run it, it's going to have something happen that I think will be interesting. All right, so what's a good wage? What would you guys like to make at your job? 40? Sure? And you had 40 hours? And you had 10 hours of overtime? Oh. So, wait a minute. What did we do wrong here? Does anybody see what we did wrong right away? That's not in the print statement. So it's good. It occurs here because that's where we're trying to use parts of this. But if I look here, it says file 13, line 13. So it doesn't have an error until it hits this line. And so here it says I'm going to take wage times 1.5. And then it gives an error. So it can't multiply. And what it's really saying is it can't multiply because I have two different types of data. What did we forget to do when we took those inputs? So, correct, we didn't put them as a float. So, what you may need to do then is put float on each one of those. So, anytime we take input, and it's really easy to forget to do that, if I need to use it as a math number, I have to have, I have to convert it to a value that we can use. Alright, so let's see what happens now if I run this. Enter the wage, 40, 40, 10. Alright, I got paid 0. So what do we still have to put in there? So we have to put in there our total pay. Now, what I don't have is a $sign, and it's not going to look like what we have over there. So let's run it. One more time, run. So 40, 40, 10. And it says my weekly pay is $2,200. Well, that'd be okay for a week, I suppose. Especially if we didn't take taxes out. So I'm going to go check it and see what it's going to tell me. So submit, or run checks. So it says, hey, I got the right solution, but it doesn't look like this. It doesn't look like it says 899.00. So how can I do that to put that $sign right beside it? And I'll leave that challenge to you guys. But it is in the slides how to do that one. Alright, so for this Sunday, make sure if you haven't posted in the discussion board that you get that done, because I will grade those at that point. Under assignments, make sure that you have done this assignment that you have to watch the video to get the instructions for. That's kind of mean. Make sure that you have worked through all these study assignments. This case study doesn't give you any points, but it's got a lot of helpful pieces as to where you go when you get through this. This one's kind of an interesting video. Make sure that you've watched it. And make sure that you've got this. So here's the video on the idle assignment. So make sure that you've got these pieces in there. All right? Any questions? Comments? Curses?